Hi everyone, I am Disha R L from East West Institute of Technology, and today I'll be talking about something really interesting and important in database management system, that is multi-version concurrency control techniques, or MVCC for short. This is a technique used in databases to manage how multiple users access and modify the data at the same time. I know that sounds a bit technical, but by the end of this presentation, I'll promise that it'll feel much clearer. So let's move on to the slide number 2, which is introduction. In database management system, many users often access or update the same data. If we don't control this properly, it can cause errors or slow down the performance. Traditional systems are using locking, where one user has to wait for another to finish, but this causes delays and deadlocks. MVCC fixes this by creating a multiple versions of the data. Readers and writers can work at the same time, no waiting and no blocking. So let's move on to slide number 3, which is also known as abstract. MVCC helps keep the database consistent and fast by allowing multiple versions of the data item to exist. So a user reading the data sees a snapshot while the another user updates in the background. That's why MVCC is widely used in modern relational and NoSQL databases. It balances consistency and speed both. In fourth slide we have problem statement. The problem is, how can we allow high levels of access without compromising the data integrity? So the simple answer is, locking system slow things down and lead to deadlock. MVCC avoid this by letting readers and writers work independently while still maintaining the isolation and correctness. So in slide number 5 we have literature survey. MVCC was introduced after traditional locking methods. Now it's widely used in databases like PostgreSQL and MySQL, and even in distributed systems. Researchers may have improved it over time but make it more efficient and scalable. In slide 6 we have software requirement. To test MVCC, we need a DBMS that supports like PostgreSQL and MySQL. Then you can also write your queries using SQL, and you can also even use Python, Java or C if you want to integrate with programs. For testing and performance analysis, tools like pgbench can help you simulate multiple transactions. And of course, you'll need an OS, that is Linux, and it is preferred by many users, but Windows work too. In slide number 7, we have program code and output. Let me explain MVCC with a simple example. We create a table and insert a value. In transaction 1, we start a transaction and read the value. While this is happening, transaction 2 begins in a different section and updates the same value. Once transaction 2 commits, the data is updated, but the transaction 1 still sees the old value because it's still working with a snapshot taken when it started. Only when transaction 1 commits, it's move forward. Then this shows how MVCC isolate the transaction to maintain consistency while allowing them to run on the same time. In slide number 8 we have output snapshot. Here is what the output looks like. Both transactions complete successfully even though transaction 2 changed the value. Transaction 1 didn't see the change until after it is committed. That's the whole idea behind MVCC, giving each transaction its own version of reality until it's done. In slide number 9, we have feature enhancement. MVCC has come a long way, and there are still ways to make it better. Some cool enhancements includes garbage collection to clean up old versions, adaptive snapshots management that adjust based on the system load, hybrid models that mix MVCC with locking when needed, compression to save space when storing multiple versions, improved conflict detection and avoid write clashes. This improvement helps MVCC work better in large system with many users. So in slide number 10 we have references. To understand MVCC in depth, I referred to a mix of research papers, technical blogs and articles. These help me to understand how different systems apply MVCC and what challenges do they face. In slide number 11, we have conclusion. So, to wrap it up all with, multi-version concurrency control is an effective way and efficient way to manage the multiple users accessing the database at the same time. Instead of making people wait, MVCC gives them their own version of the data to work with. It improves speed, avoid locking issues, and is perfect for modern system with high concurrency. And with ongoing improvements, MVCC is only getting more powerful. Thank you for listening, guys.